Welcome back. This is lesson 7 of our series on algebra, Algebra 1 beginning algebra. In this video we'll go over the properties of real numbers with commutative, associative, distributive laws, and factoring, and also laws of properties 0 and 1. This will be a great foundation for what's to come in algebra. First, we'll start off with the identity property. The identity property of 0 is simple to understand. Say you have x plus 0. If you add anything with a 0, you're not really adding anything at all. 0 is simply just a placeholder. So you have x plus 0, you would have x. Similar, if you have the identity property of 1, anytime you multiply 1 to any value, that value is never changed. So if you have x multiplied by 1, your value would still be x. An example would be, say we have 1/2 multiplied by 1, or we have 1 is equal to x over x, as long as x is not 0. Or if we have 1/2 multiplied by x over x. Since we have x over x equal as 1 because it's being multiplied, or it's being divided by itself, it would equal 1. So we're not simply changing anything, we're just multiplying it by 1, which doesn't change anything. So we have this still 1/2. So as long as you do the number over the same number, you get 1. So when you multiply anything by 1, you get the same number. So you're not really changing anything. So if we have 1/2 multiplied by 3 over 3, it would still be 1/2. If we have 1/2 multiplied by 56 over 56, you still get 1/2 because 56 over 56 is 1. Say we have 1/2 multiplied by 1002 over 1002, you still get 1/2 because 1002 over 1002 equals 1. The same applies with any variable, like y over y, still equal 1, or z over z, it's still equal 1, or even a over a, still equal 1. So as long as you have any number, and it's over the same number above, it would equal 1. Say we have 5 being multiplied by the 20 over 20, you still get 5, because the 20 over 20 is 1, and anything multiplied by 1, you get the same value. Say we have x over x being multiplied by 2 over 2. The x and the x, they cancel each other out, making 1, and the 2 over 2 make 1 also. So this would just be simply 1 times 1, which is just 1. Same thing would apply if you had them on the same fraction as 2x over 2x. The 2x is the same as the 2x on the bottom. This would still equal 1. The same would apply with we have 4x over 4x. These values would cancel because each value on the top matches the one on the bottom, and this creates 1. Even if you have them out of order like xyz or zyx, as long as the top and the bottom are all being multiplied, you can cross them off as long as they match whatever is on top matches the bottom. So all of these would equal 1 as long as x, y, and z aren't 0. They could be any value. Just to go a little extreme, just to make a point, say we have 2, 4, 6, 8, 7, 5, x, a, z, w, and we have on bottom w275 x, a, z, 6. Now, all we have to do is match up whatever is on top to something on bottom. And if they do, like 2 and 2, they equal 1. Or 4 and 4, they would also equal 1. 6 and 6 would equal 1. 8 and 8, let's draw 1 in, that would equal 1. 7 and 7 will equal 1 also. 5 and 5, x and x, a and a, z and z, all equal 1. W and w, they would all equal 1. So this whole entire problem is just 1. So you can substitute values in as long as they are being multiplied by some value that would make 1. And it would not change the total value. An example of this would be example number 3. Say we have a negative x over x. What would this equal? Well, the x and the x would equal 1, but you also have a negative value. So your answer would be negative 1. Same applies if you were working with real numbers. Negative 3 over 3, what if the negative is in the middle? You have 3 over 3, which is 1. You still have the negative to deal with, so the negative is added on to the negative 1. So you have negative 1 as your answer. Say we have negative 3x over 3x. Cross out whatever's on top is the same as the bottom, and you get 1 times 1 on top. You still have a negative on the outside, so it's like negative 1 times a 1 times a 1, which would give you a negative 1. Same thing if you have a negative 3x over a negative 3x. It would be as if you can multiply this by 1 times 1, because the negative 3's, they make a positive 3, because you're dividing by the same value, because you have a negative divided by a negative, which would give you a positive value. So it's like we multiply 1 times 1, which would give you 1. Example number 4. Say we have x plus y would equal y plus x. Or we have 3 plus 4 equals 7. Or 4 plus 3 equals 7. No matter which way you write it, they will equal the same thing. So when you're adding something together, it doesn't matter which of the numbers you add first, or which order you have them in. They will equal the same value. So 3 plus 4 is equal to 3 plus 4, or 4 plus 3, however you want to write it. The same rules apply to which way you multiply the values, like x times y or y times x. They're equivalent. So for example, you have 3 times 2, which would be 6. Doesn't matter if you write it as 2 times 3, still equals 6. So you would say 3 times 2 is equal to 2 times 3. No matter which way you flip it, you're still multiplying, and they would be equivalent. These are called the commutative laws. Law 1 deals with addition. Law 2 deals with multiplication. Example 5, we will go over the associative laws. First, we'll do the addition one. If you have x plus parentheses y plus z parentheses, doesn't matter which way you add them together, so we can write it as x plus y first plus z with the parentheses around the x and y. It'd still be equivalent. So if we used real numbers and we said 3 plus parentheses 4 plus 5 parentheses, it's just like saying 3 plus 5. Go ahead and add those. You get 9. Bring down the 3. 3 plus 9, 12. Now let's flip it. If we have the parentheses around the 3 plus 4 and 5 is on the outside, go ahead and add the 3 and the 4 and you get 7. Bring down the 5. 7 plus 5, you still get 12. The same rules apply similar to multiplication. Say we have x with the parentheses around the y and the z. Everything's being multiplied. You can rewrite this in any way, shape, or form as x times y with the parentheses around them being multiplied by z. Doesn't matter which way you write it. Say we have 2 being multiplied by the parentheses around 3 and 4. Go ahead and do the 3 and the 4 first, then bring down the 2. So you have 2 times 12, which actually equals 24. Now change the parentheses around 2 other numbers first, like 2 and the 3, and leave the 4 on the outside. 2 times 3 is 6. Bring down the 4. 6 times 4 is 24. You get the answer either way. You can write these numbers like, instead of just rearranging them for y and z and x and y, you can also just do x and z, like 2 times 4 would be 8 times 3, which would be 24. No matter which order you have them in, as long as you multiply them, you can do this. Okay, let's go over the distributive laws of multiplication over addition and subtraction. Let's do the addition first. Say we have x with the parentheses, y plus z parentheses equals x, y plus x z. What does this mean? So first, the x is on the outside of the parentheses. You must distribute the x among the y and the z because you have the multiplication on the outside of the parentheses. This is what the parentheses indicate. So first you must multiply the x to the y and then add x to the z. Let's use some real numbers. Say we have 2 times the parentheses of 3 plus 5. You don't forget to distribute. 2, do the 2 times 3 first, then use the addition, then you do the 2 times 5. So go ahead and do this. 2 times 3 is 6, 2 times 5 is 10, and 6 plus 10 is 16. Similar rules apply to subtraction. Instead of doing the addition, just do the subtraction. So, distribute the x times y, and then you have a minus, then x times z. You can also do this with real numbers. Do the 2 times 3 first, then the minus, then 2 times 5. Go ahead and do the multiplication. 2 times 3 is 6, 2 times 5 is 10, 6 minus 10 is negative 4. Just remember, negative 10 is bigger than positive 4. So the answer will be negative. Do the regular subtraction. 10 minus 6 is 4, so your answer would be negative 4. Okay, example number 7, we'll go over something called factoring. This might be a new concept to you, but don't freak out if you don't understand it. We'll go into detail later on. Factoring is trying to make it into a more usable form sometimes that is better when you're trying to solve for variables. Factoring is simply breaking it down into simple components. So to factor 3x plus 9, go ahead and write the numbers without the variables, the 3 and the 9. Factor them out by breaking them into what components they're made of. So 3 is a prime number, so all you can do is 3 times 1. Go ahead and do 9. 9 can be 3 times 3. Now, you see that each of the numbers have a common number involved, this being 3. Go ahead and put everything that's not a 3 inside the brackets. So the first bracket will have 1. Since the 3 was belonging to an x, we will indicate this as 1x. Plus, and nothing changes, the addition is still there. Now the 9. What's left over if you take away one of the 3's? You have 2 of them, so left over would just be 3. Now, the common value will be on the outside. The common between the two of these numbers would be 3, so 3 would indicate on the outside. This would be your factor form. 3 with the parentheses, 1x, or you can say x plus 3 with the parentheses. parentheses. Now, to check yourself to see if you did this correctly, just use the distributing law and you will determine if your factoring is correct. So distribute 3 to the x first. So 3 times x, and then you do the addition, then distribute to the 3 times 3. 3 times x is just 3x, and 3 times 3 is 9. So, you got your answer 3x plus 9 back. So your factor form is correct. Your factor form is 3 with parentheses, x plus 3, parentheses. Example number 8. Let's just do this with numbers without any variables. Say we have 5 plus 15 plus 30. Write out each number and make your number tree. 5 can be broken into 5 and 1, 15 can be broken into 5 and 3, and 30 can be broken into 6 and 5. They all have a 5 in common with them, so write the 5 on the outside. Then whatever's left, you bring down for each value. Since from 5 we have 1 left, we will just leave 1 in the parentheses. Then add whatever we have left for 15, which would be 3. So then we do 3 plus, then when we have 30, what's left is the 6. So you're eliminating what's in common, putting it outside, and then putting whatever is left in the parentheses. This would be the factor form. To check ourselves, we just do the distribution of the numbers. So 5 times 1 plus 5 times 3 plus 5 times 6. Go ahead and do your math. 5 plus 15 plus 30. Now we know that we've done the factoring correctly, and that is our factor form. The same thing is happening when we have variables like x. Let's go ahead and do the factoring. Say we have 5x plus 15x plus 30. We already made factoring trees for each of our numbers. Now we just have to include the x values. We know what's in common between them, which is 5, and we know what is remaining. So the 5x, what's remaining, is just 1. So we can say 1x. Now there's an addition between the next value, and we add it here. Now what is left over from the 15 is a 3, but there's still an x left over, so we also write 3x. Go ahead and do your addition between the two values. What's left over from the 30 is a 6. Similar, like above, we get all the values, but now we have x's this time, so we must include them because they're still left over. So our factor form would be 5 with the parentheses x plus 3x plus 6. That would be our factor form. Do the distribute values, so 5 times x, 5 times 3x, plus 5 times 6. You get 5x plus 15x plus 30. So you got your answer back, and that's your factoring form. Now we're going to go over something called like terms, or collecting like terms. This is a good skill to have throughout algebra and into higher levels of math, because it makes your equations simpler and more compact. Say we have 5x plus 3x plus 7 minus 2x plus 7. There are terms that are similar. All of these have an x minus the 7. So we can add the values that are similar together. 5 plus 3 is 8. These two values have an x in between the two of them. So it'd be 8x. Bring down the 7x minus 2x and also bring down the 7. Now you can do the 8x plus 7x. Just add the numbers together and then you get 15. Then you just add x because they have an x in common. Now bring the 2x down and the 7. Now you have 15x minus 2x. Do the regular subtraction. 15 minus 2 is 13 plus 7. Since 13x and the 7 don't have anything in common, this is your final answer for this simplification of this form. You can do the factoring on this equation. Simply just pull out each of the values that are similar with x. So, to factor this, 5x plus 3x plus 7x minus 2x, you have an x in common. So, the common value will go outside the parentheses. Put everything that is not x, like 5 plus 3 plus 7 minus 2, inside the parentheses, and you can leave the 7 on the outside of the parentheses because it doesn't have an x. Simply just add up all the numbers. So let's do 5 plus 3 equals 8. Now you have, bring down the 7 and the negative 2, and bring down your x and then plus 7. Now you just have to do 8 plus 7 minus 2, which is 13. Now you can just distribute the x to the 13. So there'd be 13x. Then you just do the addition, 7. So you get 13x plus 7. This is kind of a shortcut in a way, so you don't have to combine like terms maybe the longer way, but either way you can get the same answer. So you can do the factoring first, or you can just combine like terms as you go along. Either way is correct. This concludes lesson 7. You can continue watching this series. You go to our playlist and click on Beginning Algebra series. Thank you for watching. Please like our video, please subscribe, and if you would like, you can also give us support by donating to our channel. You can do this by clicking the right corner with the eye and then support this channel. You can donate to any increments of values of 1 up to, I believe, 500. I would really appreciate people in supporting our channel. Thank you. Have a great day.